Hi, my name's Treflyn Jones and I'm here again with another video. This time I want to talk to you about calories, because the world has been using the term calories for a long time now to make us relate to the way that we eat our food. But the thing is about calories, what is a calorie? Can you actually see it? Is it a physical component? Does it have a chemical formula? What can it be used for? What can you do with it? Can you eat it? Where does it come from? Where does it go? You know, we talk about calories. People say, don't eat this because it's got so many calories in it. And it's not just me saying this to you now, but very eminent people talk about calories.
Cutting down to 800 calories a day and they're still weighing 350 pounds. Then as long as you feel good, you will lose weight and continue to reduce your body fat as you restrict calories.
And I'm also going to be showing you how many calories I eat in a day.
And here are the calories.
Let's talk about the benefit of restricting calories. But I'm assuming if your calories are that low, it's going to be fat loss or losing body fat.
I've got myself a 1,000 calorie shake. Peanut butter, oats, whey, protein, bananas, ice cream. There's 1,000 calories in this, alright?
This is a doner kebab. It is 800 calories.
And there it is. That is 5,600 calories.
I'm going to show you your weight loss calorie calculator so you know exactly how many calories you need to eat in order to lose fat quickly, but more importantly, sustainably over the long term.
Okay, 1 pound of fat equals 3,500 calories. So that means that we have to eat 500 fewer calories than we burn.
I can only eat calories that I have burned. So for every calorie that I burn, I can then eat 1 calorie.
Seeing that I was eating an exact number of calories was really helpful to that, and it did, speed up my weight loss. If you're trying to put on some muscle and some weight, you might want to eat 200 to 300 calories more than this. If you're trying to lose weight, then about 500 to 600 calories less than this is a good number. So based on that, work out your number that you want to be eating each day.
So there you go. People say
it's because you're eating more calories.
You're eating too many calories. But here's the question, here's the thing. Can you eat a calorie? Well, according to some people, you can, because they say you're eating too many calories. All these videos are up on YouTube about how to measure your calories, how to count your calories. The keto diet is based about apportioning your food according to the calories that are in each nutrient.
Today we're going to talk about macros, understanding macronutrients. And macronutrients are the source of fat, protein, and carbs that make up your calories. It's where you get your energy from your food.
So how many calories in the fat? They say that 70% of your calories for that meal should come from the fat. 20% should come from protein. So 20% of your calories come from protein. And the other 10% of the calories should come from carbohydrates. So people are very used to that and they struggle. And they look at their plates and they have a carb counter or a calorie counter. And they work out on the phone how many calories are in each part of my meal. And they come up and they say, I've worked out all my macros. All my calories are spot on. But I'll ask you the question again. What is a calorie? Well, let's find out.
We're going to talk about calories today.
All right.
Calories in food. Now, calories are not bad. They're just a measure of energy. We're going to measure how many calories there are in each of these samples of food. Now, if we were food scientists, nutritionists, we would do this in a very careful and exacting way. We're going to burn these samples and we're going to measure or observe the flame that comes off. All right. So now you're getting a sense of how much energy there are in those toasted oats. So they're really toasted at this point, right?
In today's video, Amelia and I are going to show you how to measure the energy content of food. And then the next step is to add 20 centimeters cubed of water to a boiling tube. Amelia's popped a thermometer into the boiling tube so we can measure the initial temperature. Our starting temperature is 22 degrees Celsius. The next step is to set our food sample alight using a Bunsen burner. Now this is the crucial part of the experiment. We're using the heat being generated by that burning whatsit to heat the 20 centimetres cubed of water.
Peanuts are high in fat. Dried potato is high in carbohydrate. To compare their energy content, we can use a food calorimeter. It's a glass container filled with water and works like this. First, place 1 gram of dried potato into a small metal crucible. This sits on a heat-proof platform. The calorimeter surrounds the food. At this point, the water inside is at a temperature of 21 Celsius. A small ignition coil gets hot enough to ignite the potato, and a flow of oxygen into the space around the food keeps it burning. The hot gases produced rise through the copper coil and heat the water. 1 gram of potato causes the water to rise from 21 to 25 Celsius. So what happens with 1 gram of peanuts? This time, the water rises from 21 to 29 Celsius. This rise in temperature means that peanuts contain 20 kilojoules per gram, while dried potato contains 10 kilojoules per gram. Fat makes a big difference to the energy content. Burning a small piece of cream cracker in liquid oxygen shows just how much energy it contains. Food is a store of chemical energy. It's because it's in contact with pure oxygen that this piece of food burns so completely.
So, as you saw, food is taken and it's burnt in a laboratory, and the amount of heat given off that food is used to raise the temperature of a set amount of water. So a calorie is defined as the amount of heat required to raise 1 gram of water through 1 degree centigrade. I've known this for years and years and years because I was brought up in instrumentation, electronics, pneumatics, hydraulics, physics. And before that, there was a British thermal unit. It was the amount of heat required to raise 1 pound of water through 1 degree Fahrenheit. And then you've got joules, you've got kilowatts per hour, you've got horsepower. So these are all energy values. So what they do, the calorie is an energy value that's allocated to a piece of food as it's been burnt. So therefore, the better the food burns, the higher the number of calories it says it's got. But what does that mean to us? We don't have a fire inside. I know people say I've got a fire in my belly, but we're talking here about thermodynamics. Our bodies don't burn food. Our bodies don't operate like that. You know, we operate in a totally different way. You know, the fat is utilised in our body in a totally different way to the carbohydrate and a totally different way to the protein.
Hi everybody, Dr. Mike here. It's time to talk metabolism. So you know the 3 major macronutrients, proteins, fats, carbohydrates. What happens when you ingest them? Let's have a look. So you take in a burger, you take a bite, you chew it up, you break it down, you get those proteins, fats and carbs in your stomach, which then are further digested once they get into your intestines. Okay? Now what you can find is that the amino acids, glucose, glycerol and fatty acids all get taken via the portal vein to the liver. So this is the liver cell here, but triglycerides, as glycerol and fatty acids, actually get absorbed into the lymphatic system.
As you've seen for yourself, the calorie is a non-existent component. It doesn't exist.
So, to calculate how much heat energy the water absorbed, we're going to use this equation. Q equals M times C times delta T. So if we're going to do some math, we need some numbers. Let's say that in our container, we have 150 milliliters of water, which means that 150 milliliters of water have a mass of 150 grams. We'll also need to know the temperature change for the water. So, the initial temperature before we started burning the potato chip under the water is 21 degrees Celsius, and then after the potato chip is finished burning, the final temperature is 85 degrees. So Q is going to be the heat absorbed by the water. This is the variable that we're going to be solving for. M is the mass of the water. 150 milliliters has a mass of 150 grams. C, the specific heat of water. So specific heat is how many calories are required to take 1 gram of water and raise the temperature by 1 degree Celsius. You might remember that water is 1 calorie is required to raise 1 gram of water by 1 degree Celsius. So that's all you know. If you didn't remember this, you can easily find the number for heat on the internet or book. Okay, now find delta T, the change in temperature of water. So find delta T, we're going to do the final temperature minus the initial temperature. So we're going to do 85 degrees Celsius minus 21 degrees Celsius. And that's going to give us 64 degrees Celsius for delta T. Now we have M and C and delta T. So we plug these in the equation. We'll do Q equals M 150 grams times C 1 calorie over grams times degrees Celsius times delta T, which is 64 degrees Celsius. Actually, cleans this up because we have to stop. So here's our question. On Q, all you have to do is multiply this. It's going to be 150 times 1 times 64, and that's going to give us 9,600. What do you actually? Let's look at that. Your grams up, cancel. Degrees Celsius here, degrees Celsius up there, leaving us with calories. It's going to be 9,600 calories. Now we're not quite done because we don't have to this. These calories here, the answer to the question. These are different kind of calories than calories in food. In fact, there are 1,000 of these kind of calories in one food calorie. Okay, 1,000 calories of these in one food calorie. We can also call food calorie kilocalorie. Not exactly kilograms, 1,000 of these. Now, just to make it super confusing, if you spell the word calorie with uppercase C, you're talking about kilocalories, food calories, which means the calorie with uppercase C has 1,000 lowercase c calories in it. So anyway, we're going to have to integrate from these kind of calories into this food calorie. I just call it kilocalories, it's not confusing with lowercase c. Now, we can take a 1,000 millicalories over 1 kilocalorie and use that to write 2 kilocalories. 1 kilocalorie over 1,000 calories, or just flip. So, which of these are we going to use? We're starting with 9,600 millicalories. We're going to use the first factor to get rid of the calories. So calories on top here, we're going to use the first factor to get calories on the bottom. So we use this one. Now we'll plug together. We'll do 9,000 times 1 divided by 1,000. Calories on top, calories on the bottom. They cancel out, and we're going to end up with 9.6 kilocalories. Also known as food calories, or calorie calories. So 9.6 kilocalories, energy.
It exists as a number only, a value assigned to the result of an experiment in a laboratory. And as you've also seen from the video, and that's just one video of many, that our bodies do not metabolize food in any way similar to setting food on fire.
Acetyl-CoA goes through this cycle called the Krebs cycle, or the citric acid cycle, and as it goes through this cycle and turns into a number of products, it releases carbon dioxide as a waste product, but also releases ATP.
So, am I counting calories? No. Is there any point in counting calories? No. We have to stay safe. We have to understand how our body metabolizes the food that we eat. We have to understand why we cut down on the carbohydrates. We have to understand why it is that if we eat a lot of fat and we cut down on the carb content of our meals, then it could get us into ketosis but inhibit our weight loss. I made another video about that called Demystifying the Ketogenic Diet. And one thing I want to make a point of is that all the different video clips that I've used here, I haven't picked them to make anybody look silly or unlearned. You know, I've used them just as an example that people are using the word calorie. Not to show these people up, not to be unkind to them, but just to show you that people do use the word calorie a lot.
Based on this idea of pushing a caloric-centric, a calorie-centric paradigm of you have to be in a negative caloric state in order to lose weight, and thus you should exercise more to increase that caloric expenditure and eat less to reduce the caloric intake. And it just doesn't play out that way.
And if you don't know about the fact that calories are non-existent components, then you too could be misled into thinking that it's something you really have to count, and you don't. Just don't even go there. So anyway, thank you very much indeed for watching this video. Stay safe. Thanks for all the great posts on our Facebook page on the Keep Fat Club, and for all your contributions, and for subscribing on our Warrington Low Carbohydrate group on YouTube. Thank you so much. Stay safe. Bye.